Good morning. Next topic is files. A file is a sequence of records. Each record is a collection of data values or data items. A record, record may contain number of attributes. A file descriptor or header includes information that describes the file, such as the field names, their data types, and address of file blocks on disk. That is a file that contains number of records. Each record is contain number of field or attribute are of different types, and a file descriptor or header includes information that where is a file, as well as what are the field name, what are the data types, etc. A file can be a fixed length record or a variable length record. That depends on the fixed length record or variable length record. File can be spanned or unspanned. That also we have seen in the last lecture. Unspanned means no record can span in two blocks. Span means a record can be stored in more than one block. Fixed length, variable length records. All records have the same format. Usually unspanned blocking is used in such files. If the record are of fixed length, in the case of variable length, it can span in more than one block. That is why all records have the same format. Usually unspanned blocking is used in fixed length records. Variable length records require addition. In the case of variable length record, how will you fix the size of record? To fix or identify where the record ends and beginning of the next record, there requires additional information to be stored in each record, such as separate character or field types. Then only you can identify where is the boundary where a record ends and a new record starts. If it is fixed length, for example 100 bytes, it is okay. The first 100 byte is first record, next 100 byte is the next record, and like that. If it is variable length, some other characters are required to identify it's a ending of a record. And there are different disk block allocation techniques. That is first a contiguous allocation. That means a file may require more than one blocks. The contiguous blocks in the physical disk are allocated to the file. That is most contiguous allocation. A linked allocation, each block then a link to the next block. That may not be physically a contiguous location, that may be in another location. Or indexed allocation, such a type of allocation. What we are concentrating here is what are different file organized. File is a logical entity, and how different files are being organized. The three techniques, heap files, sequential files, and hashing, are the techniques for file organization, not for the disk allocation. This is for file organization. File unordered or heap file organization. In the case of heap file organization, or it is known as heap or a file, new records are inserted at the end of file. A file contains number of records. How the records are being inserted, deleted, etc., that we are dealing with. To search a record, a linear search record, because as and when a record comes, that is appended to the end. That means it is not an ordered file. It is not an ordered file means to search a record with a key value, it has to be a complete search, complete linear search. It is quite expensive. To insert a record, it is easy, quite efficient, because you just add at the end of the file only. To delete a record, copy the block into a buffer, delete the record from the buffer, rewrite the block. Reading a record in the order of a particular field requires sorting of the file records. If you want the records to be in a sorted or to be a particular order, particular field, then it must be sorted. To sort large file with number of blocks, very huge size blocks, huge size files, external sorting, that is the file size that do not fit into primary memory, then transfer between blocks between primary memory and secondary memory. Such type of sorting is also possible. One such sort method is external sorting, sort merge. That is an example of such topic. Ordered files or sequential files. Second file organization is sequential file organization. File records are kept sorted by values of the ordering field. There is an key field. Based on that, the records are kept. Insertion is quite expensive. That is, you are inserting record in different orders. That means whenever a record is appended or whenever a record is added to already existing file, that must be placed in sequential order. Insertion is quite expensive. Record must be inserted in the correct order. It is common to keep a separate unordered overflow file for new records to improve insertion efficiency. This is periodically merged with the main ordered file. The advantage of such ordered file or sequential file is search can be easy. Binary search can be used to search for a record on its ordering field value. In the case of binary search, as you know, the search time is log to the base of number of blocks. Reading of record in the order of ordering field is quite efficient. Deletion, use pointer chains. Insertion, locate position where the record is to be inserted. If there is free space, then insert there. If there is no space, insert the record into an overflow block. In either case, pointer chain must be updated. Need to be organized file from time to time to restore the sequential order. For example, here in this is a sequential file example of the order kept in the order of a field. The first field 10101 like that, 15 here 2222, and the next one is 3222. This should be inserted before. There is no space there, therefore an overflow is used. Now it is pointing here, and this record should be inserted here. A physical order is required in the case of sequential file organization. Okay, hashing for disk file is called external hashing. File blocks are divided into m equal sized block buckets numbered from bucket 0, bucket 1 and bucket m minus 1. That is, equal sized buckets are used. Typically a bucket corresponds to one or more fixed number of contiguous disk blocks. One of the field is designated to be hash key of the file. A record with hash key value k is stored in the bucket where I is equal to hash of k. That is, our key is k. We'll take a hash function, and what is it result is the bucket to which the particular data record to be stored. Therefore, to retrieve also same hash function is used that will points to the bucket where the data is stored. There is one problem. Hashing function search is very efficient. What is the order of that? What is the time required? It can be retrieved in order of 1 because you just apply a hash, then it points. There is issue there. Collision occurs when a new record hashes to the same bucket that is already full. A bucket contains number of disk blocks. When it is hashed the same bucket, if there is space, it can be appended there. Therefore, within that bucket only a search is need to be performed. If the bucket is full, then some additional techniques needs to be employed. That is what hashing saves time because you are applying the retrieval is easy, adding is also easy provided no collision. An OR file is kept for storing such records. Overflow records that hash to each bucket that can be linked together. Therefore, this is an diagram showing hashing. This is the hash table, bucket number and the block address on the disk. Therefore, 0, the bucket 0, these are the blocks. Bucket 2, bucket 1, these are the blocks, and bucket 2 similarly blocks are there. Therefore, hash function is applied. If these blocks are free, then add to that block. Overflow handling by chaining. Whenever there is an overflow, there is a record pointer that points to another overflow buckets. That is, this bucket is free, and hash function result in this bucket 1, and it is already occupied. A record pointer is used to point to another overflow bucket. The records will be added. 3219. This bucket will be added there. Okay. Now next is indexing structure that we will discuss later. Okay.